If you want a formula for the sum of a finite geometric series, we can do something like this. The most generic geometric series I stop at n minus 1 instead of n because the first term doesn't have an r in it, so if there are n terms, the last term is going to be a times r to the n minus 1. Well, if I multiply everything through by r, I get the a becomes ar, which I'm going to put underneath here, and the ar becomes ar squared. And I get this extra term at the end, ar to the n. When I subtract these, I get Sn minus Rsn equals, this a becomes a, and there's nothing here, so when I subtract, I get a r to the n. Factor out. So one version of the formula is just a minus a r to the n over 1 minus r. The thing about this formula is that you may not know what n is, so one thing we can do is we can factor out an a, 1 minus r to the n over 1 minus r. This formula actually still requires that we know what n is. Another thing you can do with this formula is just factor out an r from this ar to the n, ar to the n minus 1 over 1 minus r. The reason that's good is because this a times r to the n minus 1 is also equal to the nth term, 1 minus r. So this form is actually really useful. You take the first term, you multiply the last term times r, subtract them, and divide it by the difference there. So that's this is probably our most useful formula for these questions. Now this formula can be used for certain applications. I like this one. Imagine you put $100 into the bank. This bank is 5% interest. If you left it in the bank until the year 1/1/2040, that's 41. Hold on a second. That money itself would be worth, it's 100. Each year it gets multiplied by 1.05. That gets you how much money it's worth now. So it's going to be worth that much on 1/1/2040. And if I put another $100 in the bank, 2001, that money is going to be worth 100 times 1.05 to the 39th power by then. And if I do this every single year until 2040, that money is just going to be worth $100, not going to get any interest. And I take out all the money on 1/240. Well, the total sum of the 41 numbers would be 100. That was my most recent, times 100 times 1.05. That's the one I put in 2039, plus 100 times 1.05 squared. That's going to go all the way up to my very first payment was 100 times 1.05 to the 40th. Well, we have a formula for this. One version of the formula is A1 minus R times, actually, in this one, the better formula to use is A1 times 1 minus R to the N over 1 minus R. In this case, that's 100 times 1 minus, this is 40 here. So the formula is R to the 1.05, sorry, to the 41st power. It's always one more than whenever power was over here, over 1 minus 1.05. And you throw that in, and it becomes about $13,000, $12,784 approximately. Another application is paying off a loan. So imagine I take out $50,000 and I have a loan that has a very high 12% interest rate. So the amount of money I owe initially is $50,000, and after the first year, I want to know, I pay off P dollars each year. So after the first year, the amount of money I owe has actually first gone up to 50 times 1.12, but then I make a payment, so that cuts off some of the amount I owe. And the second year, the same thing happens. Here's what I owed. That gets increased, but then I subtract away my payment. And that thing ends up simplifying or turning into 50,000 times 1.12 squared minus 1.12p minus p. And if I do this again, a pattern starts to develop. Minus 1.12 squared p minus 1.12p minus 1.12. And in general, it becomes 50,000 times 1.12 to the nth power, or let's just say after 30 years, it would be to the 30th power minus 1.12 to the 29th minus 1.12, p, 1.12 to the 28th p, going down to minus 1.12 p. Actually, the last one is just 1.12. Well, what I have here is a geometric series, which I can solve. I want to end up with no money if I want to pay the loan off after 30 years. So I end up, when I move everything over to one side, I get 50 times 1.12 to the 30th is equal, factor out the p. I guess that last one was 1.12p. Factor out, no, it was just p. The very last thing for each of these was just minus p. So I should say 1.2p minus p. Anyway, here's where the geometric series comes up. 1.12 to the 29th. Well, this thing, we could use the formula. 1 times 1 minus 1.12 to the 30th over 1 minus 1.12. And then when you divide everything out, you end up with p equals 6,207.25. If you want to know how much money you end up paying, total paid is 30p, which is $186,217.50. If I subtract away the original 50,000, it's $136,000 in interest. So those are some applications of the finite geometric series formula.